Welcome to this episode of Retinal Realities, brought to you by Retina South Africa and supported by Roche Products and hosted today by Karen Denton. Rare Retinal Diseases Day is celebrated annually, and who better to share knowledge about this than Retina South Africa's very own Claudette Medefindt. Welcome, Claudette.
Thank you so much, Karen. And you know, as a person who has had a rare retinal disease all my life, it's really a privilege for me to sit here and talk about retinal disease in the abstract, not in the personal.
Thank you. And now, as we get started, please could you define for us just what is meant by the term rare retinal disease?
Well, rare retinal diseases fall under the umbrella of rare diseases, and rare diseases are taken that less than 1 in 10,000 in the population actually has that condition. And we know with some of our very rare conditions, like Leber's congenital amaurosis, some of the rare genetic forms, it might even be 1 in 100,000. So they are very rare. But we're specializing only today, of course, on those that affect the retina. The retina, of course, lines the back of the eye, and it processes all the light coming into the eye and converts them into neural signals, which are transported through the neural layer via the optic nerve to the brain, which is where those messages are reassimilated, and your brain and your memory tells you what you're looking at.
Wow, so the rare retinal diseases really are rare, but then how are they typically diagnosed? Are there any new technologies or advancements or anything that has improved diagnostic accuracy?
Absolutely, because, you know, previously, retinal conditions were only being able to be clinically diagnosed by a skilled ophthalmologist who had a particular interest in retinal diseases and had experience in seeing these very rare conditions, because many ophthalmologists will go through their entire career only seeing 1 or 2 people with a specific disease. But at wonderful advances of these imaging techniques like ocular coherence tomography, which use the infrared light to actually image the entire retina. It allows ophthalmologists now to examine that entire retina right down to a single cell, and then they can see exactly what's happening at the cellular level within each retina. But of course, a clinical diagnosis is only half the picture. To complete the picture, you also need a genetic diagnosis.
Yes, I would imagine. But then what role does genetic testing actually play in understanding rare retinal diseases?
Well, you know, there are over 300 different genes that have been implicated in rare retinal conditions. Some are more plentiful than the others, but most of them fall under the banner of rare. But you can imagine with 300 different genes and sometimes multiple mutations within a gene, there can be any number of slightly different conditions caused by a mutation in the same gene. And these genes code for different molecules, different proteins and enzymes within this very complicated layer of cells that we call the retina. We've got from the back, the choroid, the retinal pigment epithelium, the nurse and factory layer of the cells, the rods and cones that actually react to light, and those neural cells that I spoke about, and even down to the optic nerve. So a mutation within a specific gene at a specific space in that gene can actually cause a different disease. So if you don't have a genetic test and you don't know precisely which gene and gene mutation is involved, you really are undiagnosed, because all of them are in really advanced clinical stages of research to find out what's actually happening at that genetic level. So yeah, we are, with all the technologies, genetics and physiology and the imaging techniques, we are able to get a far more accurate diagnosis.
listening to what you're saying, then, are there any emerging treatments or therapies for rare retinal diseases that can give hope to our patients?
Absolutely. Last week, we had the announcement from Moorfields in the United Kingdom about another gene therapy that replaces a faulty copy of the gene in a condition called Leber's congenital amaurosis, which affects the vision of very young children. They are born with very partial vision. They often don't fixate on the faces of their parents. And even within LCA, there are 12 or 15 different gene variants. One of them, called LCA RPE65, there is a gene replacement therapy that replaces the entire RPE65 gene. And that's been around for some years, but it's frightfully expensive and far beyond the reach of all South Africans with this gene. But now there's another form of LCA called AIPL1, which has just gone into gene therapy a few years ago, and they've announced for the first time that the 4 children that were treated all have improved vision. So yes, gene therapy is really moving towards treating more and more conditions, and there are many types of genetic disease like Usher syndrome and Stargardt's that are on the brink of certainly of gene therapy. Stem cells, everybody wants to know about stem cells. Stem cells are cells that are grown that will replace an entire cell structure in the eye and in the body. But, we're now talking about neural cells, and I'm sure people have heard that there are stem cells that they are growing for heart conditions and liver conditions, and those are easier. But to actually regrow a neural cell is really something that has eluded scientists up to this point. But there are many other therapies. For example, CRISPR-Cas9, which is a gene editing, that if you were on a computer and you make a mistake, you would go out and cut that particular part that's wrong and paste something in that's correct. Well, they now have discovered this can be done in the human body, and CRISPR cut and replace bits of DNA in the eye is progressing and is in clinical trial. But there are many others, like in Stargardt's disease, which is also a rare condition that affects the central retina. We're looking at drugs that actually slow the deposit of the waste products in the retina pigment epithelium. So there are many, many that are really at very advanced stages of therapy and clinical trial and coming to therapy.
Fantastic. And that's very heartening listening to that. But in the meantime, what are the most challenging aspects of managing rare retinal diseases for patients and for healthcare providers?
Mostly the fact that it's incurable at this stage, and also the variation within the genes and within families even. You can't make a prognosis if a brother has Stargardt's and a sister has Stargardt's, that they will both progress at the same rate of deterioration. It doesn't happen like that. So the unpredictability, and also the fact that people are so desperate that they're willing to try anything. So people grab at straws and they see a product perhaps on a shelf in a pharmacy and they say, good for vision, and they'll take it. But some things like Stargardt's, for example, if you take a supplement that contains vitamin A, you will actually increase the rate of degeneration, because in a Stargardt patient, retina is unable to process the vitamin A into its various forms in the retinal pigment epithelium, and taking extra vitamin A will only enhance that deterioration. So I think it's very frustrating for the doctors because they can't treat it. They don't understand every single patient's journey. And that's why it's important for people like Retina South Africa to help patients along this journey of vision loss.
But then in the meantime, how can patients with rare retinal diseases manage their quality of life, especially when vision loss is a potential outcome?
I think there's some things that we can do. We can protect our general health. So, for example, if you have a condition that has a retinal degeneration, you need to maintain a very healthy diet. Don't eat junk. junk in, junk out, as we say. And also, you need to make sure that you're physically fit. You have to sleep well, because your photoreceptors that you have in your retina, are you born with that complement. But within the photoreceptors, there are little discs that contain different elements and different molecules, and they are degenerated during the day as you use them and regenerated when you're in deep sleep. So when you sleep between the hours of about midnight and 3 o'clock in the morning, that is when a lot of body regeneration occurs. For example, even the cleansing of the brain. The brain cleanses itself, and the discs in the photoreceptors are regenerated when you're sleeping. So healthy diet, healthy lifestyle, and also protect your vision against other forms of damage. For example, eye strain. And we know that people who have low vision spend most of their lives on their screens, and blue light emanating from screens can be very damaging. And we look at a rule of 20-20-20-20. Don't look at a screen for more than 20 minutes. Look away for 20 meters for about 20 seconds, and then blink your eyes 20 times. And that will help to lubricate your eyes and rest your eyes and avoid excess screen time, and especially for children. So we really need to make sure that people look after their vision, eat well, and seek advice. If there's something that you feel that you could take that might help your vision, please don't just take it. Ask the advice of your eye care professional.
Yes, and you've given us some really good advice there. Thank you. That makes me think on a totally different track. What are some common misconceptions or myths about retinal disease that you'd like to clear up?
Well, because it's inherited in different forms. You can have a dominant form where a parent is affected and transmits that whole complete dominant form to a child who will be affected. Or you have recessive conditions where the mother and the father both carry a single copy of a gene with a mutation, and you have a 1 in 4 chance that the child will inherit that condition and both copies of a mutated gene. Or you can have 2 out of 4, 50% chance that the child will be a carrier, and a 1 out of 4 chance that the child won't carry a single copy of the gene. In other words, not affected, not a carrier. And then you have got X-linked conditions where mothers carry the gene and they have, with mutation, they have a 50% chance of giving it to their children. So a lot of people think that if you're RP, you're all definitely going to have children with retinitis pigmentosa or Stargardt's, and that is not the case. So although it is inherited, it's inherited in different ways. And it's not anybody's fault. Very often people out of ignorance point the finger at the other and say, it's your fault, you did this or that while during the pregnancy or whatever. It's nobody's fault. These genetic mutations occur in every person for different reasons, but fortunately, mostly we marry outside of our gene pool and that we don't marry people who've got the same gene mutation. So genetics are not anybody's fault, but I would like to also make sure that people know if you've had a child that has a recessive condition, it's highly likely that you will have another child on a different pregnancy. It's not to say that you have that 1 out of 4 chance on your whole spectrum of pregnancies. You might have that 1 out of 4 chance on each pregnancy. So do seek advice. There are some very skilled genetic counselors, and they will explain to you your chances of passing on that gene of your next pregnancy. So seek advice. Don't just assume that what you read on the internet is absolutely true.
Thank you. And you've mentioned seeking advice from a genetic counselor. How important then is collaboration between the multidisciplinary team members like ophthalmologists, the genetic counselors, as you said, occupational therapists, researchers, etc., in managing rare retinal diseases?
Absolutely critical. And I think ophthalmologists have their special place, as do genetic counselors. And we at Retina have a really comprehensive list of people who can assist. And we work very closely with the Low Vision Centre of Learning, who have also a great list of people involved in low vision. And people who come to us and join Retina South Africa will be counselled. We do a needs assessment, and then people will be pointed in the right direction to receive the skills that they need. For example, the modern smartphones are wonderful for people with low vision. If the phone can talk to you, it can call somebody for you. All you have to be doing is actually be shown how. So please, we want to encourage people with rare retinal conditions. Just because you're losing your vision doesn't mean that you can't be a part of Retina South Africa. You can be. You may be able to be joined onto a clinical trial, but you might be connected with people who can help you, or perhaps you can help somebody else. So we need a multidisciplinary team. We need people in the field of low vision to refer people to Retina South Africa, but we also need people to step forward. And if they don't need help, then they're certainly able to help somebody else.
Thank you, Claudette. Thank you so much for your wonderful insights into rare retinal diseases, but also for highlighting how important it is for people to join, for example, Retina South Africa. And we invite everyone to tell all their friends to enjoy. And finally, of course, a huge thank you to our sponsors, Roche Products. Please remember to subscribe to the series by clicking on the subscribe button at the bottom of this page, as it will help this popular series to keep going. All our podcasts are available on www.retinasa.org.za. Follow the link under the tab Learn. Thank you.